With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Our question is PCl5 on heating dissociates to PCl3 and Cl2 because. So we over here are supposed to tell that PCl5 dissociates on heating to PCl3 and Cl2 because. That means we have to give the reason that why PCl5 dissociates into PCl3 and chlorine molecule, right? So first of all, we're going to find out what is the structure of PCl5. Now we're going to use the formula half of V plus M plus the charge if it's an anion minus the charge if it's a cation, right? This would give us the steric number or hybridization number, where V are the number of valence electrons of the central element, M are the number of monovalent atoms attached to the central element. If it's an anion, we need to add that charge and subtract if it's a cation. Now phosphorus is the central element that has 5 valence electrons with it, plus 5 monovalent chlorine atoms are attached to it. So this would be 10 by 2, which is equal to 5. That means this is sp3 dehybridized. Now in this case we have 5 bond pairs, right? And our steric number is 5. That means we have 0 lone pair, right? So we're gonna have trigonal bipyramidal geometry and the shape of the PCl5 molecule. Like this, we have axial bonds and we have equatorial bonds with chlorine, right? These are our axial bonds and these are our equatorial bonds. Now what happens over here is that these axial bonds, these are longer than the equatorial bonds, and the reason is steric hindrance. Why? Because these chlorine atoms that are present axially, they have 90 degree width to this plane, right? And hence they would have more steric hindrance because these angle are 120 degree and these are present 90 degree to this. So they would have more steric hindrance and hence these bond lengths would be larger than the equatorial bonds, right? So we can say that the axial bonds, they are what? They are larger in length than the equatorial bonds. So when we heat PCl5, what happens is that these two axial bonds, they break easily than the equatorial bonds because their bond length is greater and hence their bond strength would be smaller and hence they can easily break down, right? So whenever PCl5 molecules break, it forms PCl3, right? These 3 chlorine that are making equatorial bonds with phosphorus remains with phosphorus and there is formation of Cl2 molecule from these 2 axial bonds, right? So if you look at our option, the first option is saying that phosphorus can expand its octet. This is not the relevant reason why it dissociates into PCl3 and chlorine. Then they are saying it is a polar covalent molecule compound. Again, it's not a relevant reason. Then it is saying that it has unsymmetrical geometry. This is also not correct. The geometry of the molecule is symmetrical, but their bonds are unsymmetrical, right? 2 are longer and 3 are shorter, but it do have a symmetrical geometry. So this is also not correct option. So our correct option would be none of these, because these 3 are not the reasons why PCl5 dissociates into PCl3 and chlorine, because the actual reason is because the axial bonds are longer and hence have a smaller bond strength and hence breaks down easily to form chlorine molecule. So our answer to this question would be 4th, none of these.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.